So my name is Matthew Dytkowski. I'm working as a pre-sales engineer, primarily specializing in the private cloud and the storage technologies here at Broadberry. So welcome everyone. And yeah, just wanted to go through quickly through our agenda. So what we are going to discuss today is obviously the Broadberry and the OpenE partnership. Overall, the effects of the ransomware and what it means to all of us, and what can be done to, well, keep all these pesky hackers at bay. Then we would explain the OpenE Jovian DSS snapshots and retention plans and what it can do with regards to the ransomware. But not only this, because the snapshot and the retention plans, they can actually help you with overall backup plans and overall with, for example, setting up the test environments. Because one of the great features is of the OpenE is having an ability to create a writable snapshot called a clone, which in fact, for example, if you spin up the test environment, you can spin up another one by using the snapshot, and then you can do a lot of additional changes to it. And essentially, whenever you don't need it, you can just delete the snapshot and carry on with your regular environment. So it's something absolutely stunning and worth looking into. We also going to be discussing overall architectures of the OpenE clusters, the HA, and the disaster recovery. And then obviously, one of the better parts is the live demo. So today we are essentially encrypting our entire storage with the Wannacry ransomware, and you'll see the effect of that. And then obviously we won't be paying the criminals to unencrypt our data. Where we'll essentially show you how we can do it from the OpenE console. And during this period, later on, we'll have a Q&A session. So if you do have any further questions, by all means, please post them on the chat window. We'll read them out loud and then try to answer the best we can. So yeah, so I think how many attendees we got, because I'm just wondering, should we actually wait just an additional 2 minutes just to give everyone a chance to join and enjoy this webinar session? And yeah, so I think we'll just give it 2 minutes if that's all right, guys. In the meantime, if you can, please try to type something on the chat window just to make sure that you can actually ask the question and there is no problems there. Ah, brilliant. Okay. Oh, that's great. So we're getting some replies here. So that's brilliant. So everything works as it's supposed to work. So that's fantastic.
Perfect. Okay. Well, I'll take this 2 minutes of the spare time to introduce myself as well. My name is Wojciech Żylski, and I'm a business development specialist at OpenE. So today, together with Matthew from Broadberry, we'll be showcasing the possibilities of the OpenE solution that enables you simply to mitigate the threat of a ransomware attack. So firstly, we'll go through the presentation, as Matthew said. We will have some time to take a look at how Broadberry can build a system with OpenE. Their expertise with providing the best scenarios for the specific customer needs is very crucial here. So we are really happy that we are able to host this webinar together. And I believe we will give another minute of time just for the few more people to join us.
That's perfect. Thank you, Wojciech. And yeah, so yeah, so this is the thing. So we got another minute. So I think it's the time. If anyone prefers to have a tea or coffee, now is the time to make one. Okay. I wish I would have like a hold music or something like this, right? But hey,
You can always sing something.
uh, yeah. Well, I'm not sure if you want to hear my singing, to be honest with you, but yeah.
Well, I believe we are wandering into let's say dangerous territory.
Yeah, no, 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 because as soon as I start singing, probably we'll have less attendees than we have right now. So,
Okay.
mm.
Well, I believe we already have
I think we
quite a
can
few.
kick it off. So again, thank you
Perfect.
so much for spending some time with us, guys. So today, as we went through the agenda already, I'd like to do a short introduction about who Broadberry are and what we do, and well, overall history of our company. So Broadberry Data Systems was founded in 1989 by a person called Colin Broadberry. And essentially, we primarily started our business with building a custom-made PCs. However, obviously, the 90s were the age of the dot-com boom. So the Broadberry data systems started to work on providing our customers rack mountable solutions of well, the servers and the industrial storage. And since then, we actually expanded quite a lot, and we did expand our portfolio into rack mountable products of a variety of different cases, even rack mountable workstations, the industrial ruggedized types of the servers, and also obviously the well, the deployments of the private cloud, the storage solutions, etc. So today, the Broadberry Data Systems itself has the offices in the UK, USA, and Europe. We are, in fact, a part of a large multinational group of where there is about 400 million of capital behind us. So we have the locations based in London, in Frankfurt, in Milford, Norwood, Beverly, in Taiwan, um, in Westfield and Buffalo, Seattle, Los Angeles. So as you can see, we are present on the West Coast, on the East Coast of the USA. We are present in Europe. We do have, well, as I mentioned earlier, we have offices in Germany and London. We are heavily expanding, and we're actually building a new manufacturing facility in Netherlands. So that would significantly help with mitigating the around the issues with the ongoing supply and with the chip shortages, etc. So we are prepared to well, we actually stocking up to prepare to make sure that we can ship the servers to our customers in a timely fashion. However, today obviously we would like to cover more about the OpenE itself as well and our partnership. So on Broadberry data systems, if you go to the broadberry.co.uk, and in fact, there is a website link right at the top of this webinar, so you can click it in the meantime. Um, there is a specific Broadberry page about the OpenE appliances, and over there you have the ability actually to configure the entire system and have the pricing structure already done on the website. So that helps you to make sure that you can well, work with your budgets and make sure that you can actually design a solution which meets all your requirements. However, if I may share my screen, I'd like to show you guys a quick way of configuring the Broadberry appliance. And in fact, this Broadberry appliance, as you can see when you go onto this website, there is a variety of different appliances you can pick from, ranging from 12 bay, the 36 bay, or even the systems in 4U, where you can have a 60 bay system or 90 bay system. The beauty of these configurations is that, in fact, as I mentioned earlier, like, when you press on configure, you can select different CPUs. You can select the amount of RAM you require for your ZFS build, and as you can see, the price is constantly changing whenever I'm adding more components to it. And also, in fact, with the 60 bay system, this particular system can be accelerated by the NVMe disks. So as we all know, the OpenE can be we can attach the caching disks, which are the write cache and the read cache, the ZIL and the L2ARC drives, and we are using the NVMEs for that. And that creates a significant boost to the performance. Still, if you, for example, using the 60, 18 terabyte disks, that gives you a fantastic boost when it comes to the amount of storage you have in a single box. And when you use the NVMEs with it, the amount of IOPS is something extraordinary. You would and you wouldn't have or get it essentially from any of the 18 terabyte, just the standard spinning disks. Whenever you're ready with the configuration and you did configure this configuration according to your needs, you can essentially just create a PDF and type in your email address and generate the PDF. Once that's done, um, we would actually get the information as well about that you were configuring this system, and by all means our sales team would love to discuss further to make sure that we actually meeting all your requirements, and our technical team would discuss everything with you to make sure that overall all your requirements are met, and the box you are trying to buy is fit for purpose. Um, Another section which I would really recommend you to work with would be the book a free consultation. So what you can do if you click this button, you can actually just book some time, completely, absolutely no strings attached. We can have a conversation about the OpenE, what can it do, and what sort of a storage. What sort of storage requirements you have, and by all means, our technical team would have a discussion with you and recommend you the best way forward. So if you are unsure on the configuration, I do highly recommend to kind of like a contact through this particular form, and we can always have a further discussion about it. And as I mentioned earlier, the Intel Optane disks, which we use for the write caching, they are one of the best disks you can have for the write caching on its own. Why I'm saying that? Because the disks, the standard NVMe drives, as much as they are fantastic and they do provide the significant boost to the performance, they have a one issue sometimes. If you select the wrong one, they can wear off over time depending on how many writes you doing on these disks. And as we all know, if you are using the disk as a write cache, probably it's going to have quite a few writes coming through. So the Intel Optane disk has um, 60 drive writes per day. And what means is that in order to break it, you would need to write about 62 times the capacity of the drive per day over the period of 5 years. So it's almost impossible, to be honest with you guys, unless you, shifting extravagant amounts of data. And obviously, we do supply the caching disks in the mirrored configuration. So again, you have the protection against that. So yeah, so obviously, if you do have any questions, guys, in the meantime, later on we can discuss it on our Q&A session. However, now I'd like to pass it on to Wojtek, so he can explain the further features of the OpenE solution on its own. Thank you.
Matthew, thank you very much for the great introduction and the presentation of both Broadberry and OpenE. And I would like to add on to that. So basically, I would like to tell you a little bit more about OpenE. So we have been founded in 1998. So we have quite a few years of market experience. Our main headquarters are in Germany, but we also have branches in the USA, in Poland, and in Japan. Um, OpenE is a company which manufactures its own software-defined storage solution. This means that our products are independent from the hardware. This provides a tremendous opportunity to configure a server at your own requirements. So you can simply decide which manufacturer you want to build your hardware on and apply the OpenE product on top of that. When it comes to the hardware, we have ongoing partnerships with the likes of Intel, Supermicro, Toshiba, Western Digital, and Mellanox and Atto. But we also focus quite a lot on virtualization capabilities. So we have a cooperation ongoing with Citrix, and we have a certification with VMware, which proves that our solution is ready to cooperate with the VMware products. So, as Matthew mentioned before, the cooperation between OpenE and Broadberry has been ongoing for 11 years already. Broadberry is our platinum partner, so this is the highest level of commitment between our companies. OpenE works through a network of partners who act as our resellers or distributors, but most importantly, they act as the integrators who combine the hardware with our software to create a tailor-made solution for the customer. In this case, we can always make sure that the customer gets exactly what he requires in regard to his specifications. So let's move on to our main topic of today, which is a ransomware attack and how to mitigate it with OpenE Jovian DSS. So firstly, we wanted to say a few words about the ransomware itself. What is it? How does it work? So a ransomware is a malicious software that is intended to infect a machine and to encrypt the data which is connected to it in a way that it is no longer accessible to the user. So once the ransomware attacks, it encrypts all of our data and it shows us information that our data was encrypted. In order to decrypt the data, to regain the access to the data that we require, we have to pay a ransom. Now, if we actually decide to pay the ransom, the encryption will then start, but we have no guarantee that all of our files will be decrypted. Also, some of the files might be broken or simply corrupted during the encryption and decryption procedure. So if we decide to pay the ransom, we have no guarantee that all of our data will be there once the decryption is finalized. If we do not pay, however, well, our data remains encrypted. It's not accessible to us. And actually, there is another threat which is connected to it. So firstly, a ransomware was simply about encrypting the data and demanding a ransom in exchange. Right now, however, we see that the ransomwares more often start to work in a way not only based on encrypting the data, but by also seeding the data out into another location from where the attackers can then offer the data, sell them to the general public. So in this case, even if we do pay the ransom, we have no guarantee that the data wasn't leaked outside. If we don't pay the ransom, this is the same situation. So is there any good protection against the ransomware? Of course, we can work in a way to minimize the risk of a ransomware attacking us. We can invest in firewalls. We can apply strict policies when it comes to data and emails incoming from outside sources. But unfortunately, there is always the risk that the ransomware will somehow reach our system. A little bit about the current ransomware trends. So, as most of the cyber criminal acts, the numbers of ransomware attacks have been on the increase in the past few years. The main focus of the cyber criminals usually are public organizations and large companies. But we have started to see more and more attacks targeting even medium and smaller companies. Whenever there is a strong reliance on data, then the company can be a serious target to a ransomware attack. It is also worth mentioning that for some time already, the ransomwares have become not a single attack, but we call those chain attacks, which are quite often directed at whole organization or the services provided by it. In this case, we can point out as an example to the Kaseya attack from 2021, which affected at least 1,500 of managed service provider customers. So, as we all probably know, since the start of the COVID-19 pandemic, enterprises, companies, and governments around the world have been forced to move more and more of their work into the cloud and into their networking capabilities. And this, of course, has translated into a huge increase of the ransomware attacks in recent years. And by saying huge, I mean an increase of nearly 600% worldwide. So we can see that this is a trend that is increasing. It has been increasing before, but the rate of the increase right now is really tremendous. For example, the insurance company CNA Financial had to make the largest ransomware payment to date. And this payment totaled to 40 million US dollars. In the world we are living in right now, in 2022, we believe that a ransomware attack happens somewhere in the world every 10 seconds. In 2021, this was every 11 seconds, but with the trends of the ransomware attacks rising, we believe this will be even more this and the following year. When it comes to the effects of ransomware, we have to take into consideration a few factors, but one of them is the already mentioned fact of the double extortion method. So not only the data gets encrypted and a ransom is demanded, but also the data is extracted outside and a second ransom is demanded in order not to sell those data into the public. In the UK, this has been really, I would say, popular. It might not be the best word, but unfortunately, that's what has been happening. And UK is actually the third most targeted country by double extortion methods, only behind US and France. And as you can see, the increase in this double extortion ransomware method has been really terrifying. This is 933% of an increase in double extortion ransomware attack since 2020. And this is really a big problem, and we can see it is being taken seriously. So the National Cybersecurity Center has characterized the ransomware as the most significant threat facing the UK when it comes to cyber criminal activities. On this slide, we can see that there are some very worrying data when it comes to the ransomwares in the UK. Firstly, a report covering 2020 and 2021 shows that more than 80% of UK organizations experienced a successful ransomware attack. 80%. This is how many of the market has been affected. And well, in a 12-month period of 2020 to 2021, 55% of UK organizations, public organizations, were affected. So we can definitely see that this trend is definitely worrying. And what we can also see is the table on the right, which shows us the percentage of budget that the companies devote to cybersecurity. As we can see, the UK is not that high on that list. Actually, it's, well, somewhere near the bottom. This might also be the reason why the ransomwares have been targeting UK-based organizations and companies in the last 2 years. And something to put a ransomware attack into perspective, we have been talking about the biggest costs, the numbers of the ransomware attacks, etc. But what does an individual ransomware attack mean to a company? Well, on average, the cost of a single ransomware attack in the UK was $840,000 US dollars. So this is the scope that we are looking at here. When we think of the effect of the ransomware, we have to look at it twofold. First of all, there is the ransom that you have to pay in order to get the data decrypted. But second of all, while the data is encrypted, it is not accessible to us. So we are experiencing a downtime. And the downtime can be, well, it simply depends on how fast the company reacts and makes the decision to pay the ransom. But it really is up to the cyber criminals to decide when they are going to decrypt our data. So the downtime is one of the most significant effects that the ransomware has on a company. If there is no access to the data, the company cannot provide its services to their customers. If we are not only looking at the downtime itself, we are also looking at broken SLAs, we are also looking at lost trust with the customers, and quite often simply about our customers resigning from our services simply because the ransomware has caused too much trouble to them. And well, the downtime, the average cost of the ransomware cost downtime in 2021 was $380,000 US dollars. So we would have to add this to the average ransom that has to be paid, and then we get the total cost of a ransomware attack on a company. We have mentioned before that the ransomwares usually target government organizations and public institutions, but we see that there is a growing number of attacks that also target other sectors. Usually those are big international companies from technology, manufacturing, or finance industries. But unfortunately, the ransomware attacks quite often target educational and healthcare organizations. In those cases, we know that the effects of the ransomware attack do not stop at the financial costs the company has to take. And focusing especially on the healthcare part of the ransomware attacks, there have been quite a lot of those happening in the UK. So the UK government and the UK Ministry of Health officials have already mentioned the problems with the ransomwares. The strict policy of the UK government is not to pay the ransom on a ransomware attack, even though they admit that fixing the costs of the infrastructure and the time it takes is really a big trouble. For example, rebuilding the Hackney's affected system had a cost of around £10 million. Well, this is definitely something to think about when it comes to the ransomware. And now, getting more to how OpenE Jovian DSS can help to mitigate the effects of a ransomware, I will move on to shortly brief you on our product. So our OpenE Jovian DSS is a software-defined solution for storage purposes. We have won many awards for our Jovian DSS system, most recently the 2021 DCS Awards for the ICT Storage Product of the Year. So Jovian DSS is a ZFS file system and Linux-based storage server. This is the software that enables us to manage the storage and to manage the hardware level that allows us to store our data. OpenE Jovian DSS comes with a number of enterprise-grade features. For example, thick, thin, and over-provisioning, inline data deduplication and compression, self-healing, great scalability, and I'm talking here about petabyte scalability, and of course, tiered RAM and SSD caching. When it comes to Jovian DSS, what's really so fantastic about this software is that it's extremely user-friendly. Our graphical user interface allows the user to quickly and easily manage the system and to input any changes if necessary, as well as configuring the space or, for example, expanding it, which, thanks to the ZFS-based nature of the system, can be done by easily adding disks and, well, simply adding the resources into our system. As the ZFS file system manages the hard drives itself, there is no need to create any kind of hardware RAID. Thanks to that, we have a much clearer view of each individual disk itself. We can know what is the state of this disk and its health much better than in the case of a hardware RAID scenario. So apart from our graphical user interface, Jovian DSS can be accessed via, well, a simple command line or REST API. It also allows for a great amount of monitoring and logging of the events. We have a full support for protocols such as iSCSI, NFS, Samba, and Fiber Channel. As already mentioned, we have a great cooperation with virtualization services, and we also work in hyper-converged environments. With OpenE Jovian DSS, we showcase our flagship solution of on- and off-site data protection, which I will get to in the next slide, which is achieved by a high availability non-shared storage cluster, which we call a metro cluster. So, How does on and offsite data protection work in OpenE Jovian DSS? So when we think about the high availability of data and the safety that it requires, in an on and offsite data protection, we usually deploy a cluster which can be spanned across 80 kilometers. This is a non-shared cluster if we guarantee a direct FC connection between the nodes. It can be even up to 80 kilometers of distance between the two nodes. As you can see here on the slide, we have a production server and a local backup server. The local here is what I am talking about right now, which can be even up to 80 kilometers. So between those two servers, we have an ongoing synchronous replication, which translates into having the same data on both of the systems at the same time. If anything happens to the production server, the access to the data is provided instantaneously by the backup server. Apart from that, to make sure that our data have a safe copy, we create a third unit. We call it the offsite backup server. This can be stored even further away at another location. And we create the copies of the data, the backups, and we can send them this time asynchronously to the offsite backup server. This allows us to have copies of our data in 3 separate locations. In a matter of fact, if we wanted to create more than one offsite backup server, we are definitely free to do so. We can set up those copies in a few places to have even greater safety and even greater resistance to some disasters. So I have mentioned the process of backupping our data just a moment before. And in OpenE Jovian DSS, the backup is done via a snapshot. So a snapshot is what you can imagine as a photograph being taken of your data, which simply checks what data is present there on the system, and every other snapshot taken will simply compare the differences between the first snapshot and the other snapshots. Thanks to that, the snapshots itself do not consume a lot of space. So this solution allows us for great storage effectiveness while having a great data safety at the same time. With OpenE Jovian DSS, we can quickly and easily create retention plans to decide how many snapshots are created, how often, for how long they will be stored, and if we want to send those snapshots also to another location. So, as in the case of an on and offsite data protection, we can have the copy of the data on the local server, and then we can also export this data to another secure location. Now, what is really important about the snapshot itself is that the snapshot is a read-only file. And this is the key to our way of mitigating the ransomware threat. Apart from the fact that a snapshot can allow us to revert from a ransomware attack, it also gives us the possibility to access old data or simply to restore old data. As you can see on the slide, the data can be accessed via a simple way in the Windows system, and this can be done without any kind of administrator help. So, we have already covered the snapshot itself. We have already told a few words about the retention plan. So let's put it into perspective into this diagram. As we can see, we have a production server which has the data stored on one volume. And on the same server, we can create the ZFS snapshots, but on a separate pool. So we have two separate pools which have our data in two totally separate locations, even though this is the same server. Now, secondly, we can export those snapshots to another server, in this case, the backup server, or the second server, which we have in the same location. Either way, as the snapshot is asynchronously transferred to another server, we can have a few of those and have an even greater safety of the data that we store. And this is probably a little bit explained even better on this slide. So we can see a diagram showing how we actually connect our Jovian DSS with the clients. We can see that we have two OpenE Jovian DSS nodes. Those nodes are the cluster, the high availability cluster, which simply allows the system to provide constant access to the data, even if one of the systems is affected by, for example, a natural disaster or a theft. The second unit will instantaneously switch and provide the data to the client. Apart from that, we exchange the data between the two nodes constantly, both when it comes to the data itself and when it comes to the snapshots. To guarantee even better data safety, we then export those snapshots to, for example, another local Jovian DSS unit. Let's say it's in the same building. Let's say it's 2 floors higher. Already, this is a different location, so we have another, this is already a third copy of our snapshot data. And then we can even extract those further on to another remote site, which is far, far away from the main one, giving us another level of data protection. So let's put it all into perspective. And I would like to show you how to recover from a ransomware attack. In this case, I will show you the Wannacry ransomware. And well, I will simply proceed to infecting our Windows machine with Wannacry ransomware. And I will show you step by step how easily with OpenE Jovian DSS you can revert to the state from before the attack. Okay, you should be able to see my screen now. Matthew, can you please confirm? Oh, yes, okay, I do have the confirmation. Thank you very much. Okay, so what you're looking at right now is the OpenE Jovian DSS graphical user interface. This is the home of the system from the user's perspective. As you can see, we have information about our pool, about resources that are available. We have some local disks which have not been assigned to any pools, any data groups yet. But of course, we have a pool created here. We can see the specifications of it. We can see the data. We can see the state of every disk group. And we can see our Snapshot tab. This is where we can see each snapshot taken. For example, here we can see that there was a snapshot created on the 25th of February at 4:10. Okay, There are numerous options when it comes to the snapshot itself, but the snapshot had to be created somehow. This is where our Backup and Recovery tab comes into play. As you can see, we have a retention plan already created. Currently, this replication task is disabled. So what I'm going to do is to enable the task. And we have the task enabled. So what can we actually see here? The retention plan created here means that every 1 minute there is a snapshot created which is being stored for 1 hour. Then on top of that, every 15 minutes there is a snapshot taken of the snapshots which is being stored for 3 days. And on top of that, every hour there is a snapshot taken of the previous snapshots which will be kept for 2 weeks. This allows us to have, first of all, the most recent copies of the data available, but on the other hand, allows us to limit the amount of snapshots that we have. In this way, we will keep the bigger snapshots for the longer amount of time, which have the most recent snapshots snapshotted in itself. When we return to the storage page, we can actually see that our snapshot has already been created. This is from today. This is the 2nd of March. And we can see the time is right. This is probably confusing for our audience in the UK. We are operating from Poland at the moment, and the timing here is Central European time. Oh, okay, and we can see also another snapshot created a minute later. So let's move on to the actual ransomware attack. We have a Windows client here, which is connected via our vSphere. As we can see, the system is running. We have some files here. They can be accessed. They can be read. So everything is like a normal day. Okay, so now I am actually going to open this file. I do not recommend anyone to do the same because this is a ransomware. Okay, yes, I am aware of what can happen, but I'm going to press run. Okay. And oops, as we can see, your important files are encrypted. Well, our system tells us that it was the victim of a ransomware attack. We can see that Wannacry window will show shortly, and the message claims that our data have been encrypted. Well, let's see if this is in fact the case. Okay, let's open the files. As we can see, the file is no longer readable. It has been encrypted and is no longer viable to me. Here we can see a message. This is actually in Polish, but I can apply it in English. That tells us that, well, something has happened to my computer and it has been attacked by a ransomware attack. It tells me that I have to make a payment, which is, well, this is quite a cheap one, $300 worth of Bitcoin. And I have to make the payment to a certain Bitcoin wallet. And unless I do not make this payment in, well, 3 days, my data will be lost for good. In a normal case, I would probably have to go and, well, decide whether to pay the ransom or not. But luckily, I'm using OpenE Jovian DSS, and I do not have to worry about this. So the first thing I'm going to do is I'm going to stop my virtual machine. Okay. Then I'm going to go back to my OpenE Jovian DSS graphical user interface. I'm in the Snapshot tab, and I can see there are snapshots here. Now, some of the snapshots might have been already created when the ransomware was already in my system and has already encrypted my data. But there are also snapshots which were created before that happened. So I can select this, and when I go into the menu, I can see there are a few options. I can delete the snapshot, probably not the best idea in this case. I can get some more details about it. I can clone it, and the cloning possibility is really useful. For example, if I want to create another data share, which will be with exactly the data from this moment, so not taking into consideration any of the changes made after that time. But what I need right now is to roll back. So the system will tell me, first of all, that I am attempting to perform a rollback. At this moment, if I perform the rollback, I will remove 5 snapshots. Of course, those will be the ones created after the snapshot I am reverting to. And then all the new data will be permanently lost. Well, my data has already been encrypted, so it's, well, as good as lost. So to proceed, I have to type in rollback in here, and I have to hit apply. This can take a short while. And after this process is completed, as you can see, yes, we can see that all of the newer snapshots were deleted. We reverted to the snapshot of the data created at the 2nd of March at 12:47. Our backup task has been disabled automatically because we have decided to do a rollback. This is to prevent from creating additional snapshots because we might not need them at the moment. We are already reverting to a previous state of the system. So let's move on to getting our system back on its feet. This part can take between 10-13 minutes in our case. So while I wait for the system to rescan the resources and be available again in about 10-12 minutes, I think we can start the questions and answers section right now. So I'll be watching closely if the system is already good to go. And in the meantime, please feel free to type in your questions. And well, we'll do our best to answer them here right now.
Thank you, Wojciech, for an amazing presentation. And indeed, we do encourage you guys, if you do have any further questions about the OpenE and its usability, please feel free to type in the chat window, and we'll happily answer them for you. Okay. So I guess in the meantime, I'll speak about the Broadberry a little bit more as well, because pretty much I'd like to share my screen again, guys, because what I wanted to show you as well, apart from what we're doing at Broadberry, I wanted to show you our broad portfolio of the products we do. Because in fact, what I should mention earlier is that Broadberry Data Systems itself actually is specializing in a custom-made solutions, and that means also solutions which are not manufactured or well offered by different vendors, and that's what essentially helps you to create the configuration slightly better kind of like a tailor to your needs. And in fact, we do have the variety of different like edge machines, the machine learning machines as well, which in fact are well, we can offer them with the RTX 3090s. We still provide the blower edition systems for yourself. So let me just quickly show it to you, and let's have a look. And in the meantime, obviously, there you go. We've got the question. So how do we know which snapshot is previous to the encryption when the crypto ransomware is stealthy? Trial and error?
Oh, yes, I have expected this question, and thank you very much for bringing this up. So basically, back in the day when the ransomware was downloaded, or it got into our system anyway, it usually attacked at the same moment. But as pointed out here, right now, more than quite often, the ransomware, once downloaded, will become nested in our system in what is called a stealth mode. So it will not become activated. It will not encrypt our data for a given amount of time. This can be different. It can be a week. It can be a month. And the question here is, how do we know which of our snapshots is free of this ransomware? Well, we do not know this in particular because we would have to know when the ransomware was downloaded exactly. But what this solution gives us as a possibility is either to revert back to the state from just before the encryption. So we are reverting to, like in this case, to a snapshot from 5 minutes ago. We are aware that the ransomware is somewhere in our system, but it has not encrypted the data yet. So first of all, we have access to the data. We can make an additional copy of the data. We can work on the data, or we can simply isolate it. So we already have the knowledge that the ransomware is there and it will strike in about a few minutes. So we can, in this case, decide, okay, we know there is a ransomware somewhere in the system. We can, well, simply have our team or hire a third-party agency to perform a checkup of the system to find, isolate, and delete the file. So this is one case. We have the ransomware nested. We get the ransomware encrypting our data. We revert to the state from just before the encryption, knowing the ransomware is still there, still stealthed, but it's in our system. And then we have some time to play with our options. What do we do? Now, the second option is we can actually revert to the snapshots from before the ransomware was nested. This might be a little bit of a guessing game because we cannot be sure how long the activation period of the ransomware is. But quite often we can find such information on the internet. If such ransomwares were already solved, if they were already researched in some way, we will probably know what is the nesting period of the ransomware. So we can either revert to a snapshot from before this malicious software has entered our system, or we can revert just to the moment before the encryption. This all depends, first of all, on the stealth period of the ransomware, and second of all, of the characteristics of the data that we store. If there were not so many data added in the last month, then maybe it's okay to revert to a snapshot from before that time. Now, it simply comes to a simple calculation of the costs. What will be, let's say, less expensive for our company? Do we prefer to revert to the data from a month before, or do we prefer to revert just a few minutes back, secure the data, or simply get someone to explore our system, find the ransomware, exclude it, and delete it? Okay, I can see there is a second question.
Yeah, sorry, I just wanted to add to also the first question. So, as Wojciech already mentioned, the good thing is that when you know that you're going to get encrypted, you can actually revert back to the situation where you were not, and that allows you to salvage your data, which means that you can move it away to well, for example, your VHDX files or your VMs, try to move it somewhere else where the payload is not being activated. So that kind of like gives you a bit more breathing space as such, and that pretty much well allows you to still have the data which is not encrypted. But yeah, the question about the stealth is very good, but I hope we do have it cleared by now. So yeah, we have another question indeed.
Actually, before we go into the second question, I can
Yeah.
see that our system is already good to go. So let me just finish this ransomware presentation, and then we'll get back to the Q&A to answer all the remaining questions. So as we can see right now, the system is ready to be powered on. So this is what I'm going to do. Okay, and well, our machine is back up. Our system is here. And as we can see, the files are here. They are readable. They are working. And well, okay, the ransomware might still be somewhere in the system, but our data are intact. And this is the biggest advantage that we have, because at this specific moment, when we have reverted to the state before the encryption, no seeding of the data can proceed outside of our system. So not only we mitigate the threat of encrypting the data, but we also mitigate the threat of the data being extracted somewhere else. So right now, we can also decide to, okay, I know a ransomware will strike in about 2 minutes. I can isolate the system. I can shut it off from any kind of access to the general network. So first of all, my data definitely will not be extracted anywhere. And second of all, I can decide what to do. As Matthew said, I can already start salvaging the data, or I can already start working on finding the ransomware and deleting it as it is before an encryption takes place. So this is basically it for the live demo. Thank you so much for taking part in it. And as promised, let's get back to our Q&A session right now.
So there is a question: are there any capacity limits of OpenE Jovian DSS?
Okay, when it comes to the capacity limitations, right now, the ZFS file system hasn't reached its capacity limitations. This simply means that with the current technology and with the current amounts of data generated and available, there is no possibility to, well, reach the limitations of OpenE Jovian DSS. This is thanks to the ZFS file system and its immense capabilities of, well, first of all, managing the space, and second of all, of the scalability it offers.
Thank you for that. And I can say from the Broadberry perspective, we've deployed the clusters as big as 10 petabytes without any issues at all. And they still in production, chugging along. And obviously, even customers, they still expanding them with the additional JBots. And that's actually one additional great feature of the OpenE system is that in the future, if you ever need to expand your existing data pool, you can do it with the new disks. And those disks would contribute to the overall performance of the whole pool on its own. So that's the great thing which you can do, and you can do it online without causing any downtime to your existing shares or your existing iSCSI targets, etc., etc.
That's true. That's true. And well, mentioning what Matthew just said a minute ago, he mentioned that in fact Broadberry deploys OpenE run systems as big as 10 petabytes of capacity. Right here at OpenE, we can also mention that right now we have systems running over 20 petabyte of data in high availability clusters. Our systems are deployed by governmental institutions and international enterprises where the data safety and their high availability is simply crucial for the existence and operations of the entity.
Okay, so we have another question. So is there any limits, theoretical or practical, on number of disks managed by one head node server? So I'll probably answer this question. So not really. I mean, your only limits are how many HBAs you can have in the system and
Exactly.
what one HBA can control. Some of the HBAs from Broadcom, for example, the 930516E is actually capable of controlling 1024 disks. So if you have multiple of those, then well, your possibilities are virtually unlimited. So yeah. You can have as many drives as you can. However, as I mentioned earlier, like we have the solutions up to 10 petabytes within the 60 bay JBots, or even we have the JBots which are in for you in the rack depth of 1600 millimeters. We are capable of giving you a JBot of 102 drives in one for you. So I guess it's more of a physical limitation of your data center or rack cabinets rather than anything else, because the SAS cabling can go up to 25 meters. But obviously, to kind of like keep the solutions neat, I think ideally you want to keep them in like a one head node and then full of the rack space, and then probably proceed to another head node and more of the JBots. And so you can treat the solution as per rack. Because when you have it as like a modular solution, then well, it's just essentially easier to manage. Okay.
Exactly. So basically, the limitation here when it comes to the number of disks is simply hardware related. As Matthew said, when you count the limitations of an HBA controller, you get an amount of disks, then how many HBA controllers you can get. But this is also a question about what amount of disks will the hardware be able to process in a way that allows you proper performance. So for now, as mentioned before, there are no possible limitations on OpenE Jovian DSS itself. It's simply about the hardware and the hardware technology, which provides and will provide even greater possibilities when it comes to storage capabilities of the product.
Okay, so we have another question. What is the maximum distance between the two servers in a cluster? So I guess that's the question about the Metro cluster, one of the stretch clusters, which is one of the configurations possible with OpenE, which is in fact quite great for the companies and the organizations which have the multiple sites and they would like to have this failover capabilities. So As far as I remember, at the moment it's 50 miles or 80 kilometers. Please correct me if I'm wrong, Wojciech. So yeah, so this distance, in fact, it all depends as well on your link in between, because if you have the latency of like a local LAN and you've got a dark fiber running between your two sites, then these sizes can be actually even higher. The distances can be bigger.
Yes, this is basically as Matthew said. So when we look at the Metro cluster, which is a non-shared storage cluster, so this means that we have two nodes, and each of the nodes has its own individual storage underneath. Then in here we are looking at a synchronous, so constant replication ongoing between both of the nodes. So there is a mirror path going on between the nodes, which exchanges the data continuously. If the data is being written to node A, then node A sends the data to node B, which also writes it into the storage. So in this case, what we require is LAN-like latency. So we're talking about 5 milliseconds of latency. And as Matthew said, if you have a direct FC connection between the two nodes, a direct and a dedicated connection, which can provide such a latency, then yes, you can stretch it even up to 80 kilometers. Now, when it comes to the second type of cluster, this is a shared storage cluster. Here, the distances are a little bit less. Simply, well, they are affected by the limitation of connecting the same storage physically to both of the nodes. In this case, we are usually speaking about the cluster on the whole being in the same room or in the same building, with one node in room A and the other node in room Z, okay, at the other end of the building.
Although it's worth mentioning that if we go with the shared storage approach, which you can see on the screen, um, you can actually create the replication tasks between the clusters or from cluster to the single, like an OpenE node. So you can create these backup or recovery plans or disaster recovery plans using just a standard asynchronous replication based on the snapshots, which in most cases works absolutely fine. And then your distances are virtually unlimited, so you can do the geographical replication between the different regions as well. Yeah, so that's pretty much it. Are there any further questions? Okay, we got someone else is typing, so let's have a look. Okay, so we got a question from Daniel. Is replication synchronous in the sense that a write operation is not acknowledged to the host until it's replicated? If so, a few milliseconds of round trip time for replication can be an issue.
Okay, so when it comes to this, this is definitely a more technical question. I can address it. Well, sorry to say this, but with my limited knowledge,
I can try to answer it. So
um,
essentially,
yeah, both
yeah.
Matthew and me will give the same answer. And before Matthew gives the answer, I can actually give you an also other way of getting an answer for many of your questions, and especially the technical ones. I'm going to type our pre-sales team email address into the chat, and our pre-sales team is always happy to answer any kind of questions which consider the product itself, the possibilities, the topologies, and such technical questions as well, explaining how exactly our system works.
Yeah. However, answering the Daniel's question, indeed, the replication is synchronous for the stretch clusters. So that's why we mentioned that ideally you want to have a LAN-like, a local LAN performance between your sites.
Exactly.
So if you have dedicated fibers between the sites and your latency is below or equal to 1 millisecond, you are absolutely in a perfect spot. In fact, the tolerance we have at the moment are up to 5 milliseconds. So still you can tolerate certain delays. But indeed, anything over that can create a slight issue, and we would recommend then using like a local clusters and simply replicate the data using the asynchronous snapshot based replication. And I hope that answered it for you. Okay,
Exactly.
right.
So as Matthew said, this would pose an issue if we didn't follow such strict requirements when it comes to the connection between the nodes. The whole idea of the metro cluster, sometimes called a stretch cluster as well, or simply a non-shared storage cluster, is that the connection between the nodes has to be LAN-like. So if we actually want to stretch those nodes up to 80 kilometers, we need to guarantee that the connection between them will provide the required connection speed. Otherwise, the units can stand right next to each other, and well, we will have the LAN-like latency because it is a LAN environment.
Correct. And just to finish, guys, I just wanted to show you as well that in fact, what we didn't mention is that OpenE can happily, apart from the hard drives and standard SSD disks, you can easily build solutions based on full NVMe arrays. And you have a whole range of the NVMe section in our storage section and all flash storage arrays. And we would be more than happy to guide you through it because obviously the performance is something extraordinary. And also, worth mentioning that OpenE does support the Mellanox or Cisco adapters, or well, actually any other brands. But what I'm trying to say is that we do support the Ethernet speeds of 50, 100, or even 200 gigabits a second. So you can really create a really robust solutions and super which do provide fantastic performance. And obviously, they won't break a bank. So, from my side, I just wanted to thank you all for attending. Really appreciate the time you guys spent with us. If you have any further questions, you've got the email address on your screen. So please, by all means, do email me on matthew.dytkowski@broadberry.co.uk. You can actually email me as well at matt@broadberry.co.uk if it's easier for you. And thank you again and have a fantastic day.
Well, as Matthew said, thank you very much, and of course, a big thank you to Matthew as well for hosting this with us. Thank you for the great opportunity to share our joint solution with the public. So yes, please do contact Matthew at his email, either the one on the chat or the one on the screen. You can also contact OpenE directly. That would be pre-sales at opene.com if you want to reach our pre-sales engineers team. And you can also contact me at wojciech.żylski at opene.com. I will try to answer all of your sales questions as well.
Thank you very much, guys. Take care.
Perfect. Thanks a lot and see you another time. Bye bye.